we've just gone through starting our tic-tac-toe example, and let's continue where we left off. So where we left off is we've made our moves. So we've asked player 1 and player 2 to make their moves, and we were able to make the moves, and we were able to print them out in the current field. So if we run our program again, we'll just see it. We print out our current field that's empty, and then we print out that it's player 1's turn. Then we enter a row, so let's say row 1 and column 1, and then we make the move and we print our new field, or a kind of representation of our new field, and now it's player's 2 turn, and we enter the row, so let's say row 2, column 2, and now we make the move for player 2, and we put their move in here, which corresponds to column 2, so the third element of the big list, so 0, 1, 2, so that's column 2, and row 2 is 0, 1, 2, so that's row 2. So we've made the move for player 2, and now it's player 1's turn again. So for example, here we can put in row 1, column 0, so that gives us our first element. So column 0 is our first element in the big list, row 1, row 0, row 1, so that gives us this middle element here. So we make the move for player 1 again, and now it's player 2's turn. So we've been able to create, or we've been able to save these player moves inside of this list, or this nested list, so 3 lists inside of a big list that is supposed to kind of resemble our playing field. And we've also made a draw field function which can draw the field for us. Now what we need to do is we need to get our playing field into our draw field, and we want to be able to just kind of be able to draw this out inside of this tic-tac-toe field. So let's stop our code, or let's stop this instance, and let's go about that. So let's try to put our current field into this draw field, and each time we'll just draw the field that we have. So how are we going to go about that? Well, what we need to do is we need to add an input to our draw field, and so into our draw field we're actually going to add the current field. So yeah, we're just going to put this into here, and so this is going to have kind of all the data, all the moves, and we'll put that into the draw field, and we'll use this information inside of this draw field function to draw the field. So our input is going to be our field, and so this is just going to be the local variable name that you're going to. We could technically also call it current field, but let's just call it field to indicate that technically this thing here and this thing could be different. They're not different, but the names could be different. So we'll refer to it as field in here, even though we're actually talking about the current field, but we'll only use that when we actually input it in the code. So we'll see that in a second. But in here, let's just assume we have a list like this, and we assume that the list has 3 elements, and each of these elements is itself a list and has 3 elements. So that's kind of the format that we assume for field. And so how are we going to use this? Well, what are some things that we need to change? Well, we need to change, in here we need to change these values. So we need to change the actual values, and we would rather use the values from here rather than just putting them in manually. We actually want to use the values in the field. So we can keep our vertical lines, our vertical separators, and our horizontal lines, so our horizontal separators, but we do want to use the values here from our current field. So how are we going to go about that? Well, let's go through this again. Let's see what we're doing, and then let's see how we can get out the values from our field. So what we do first when we draw the field is we go through row by row, and we start in the range from 0 to up to not including 5, so 0, 1, 2, 3, 4. So our row goes 0, 1, 2, 3, 4, and if it's an even number, we go into this statement here, and we enter another for loop, and we go through column by column. Now, for even columns, we go into this if statement. And the even columns are the ones that interest us, because those are actually the ones that give us the values of the players. So the moves of the players. Either it's an empty field, so nothing has been done, or a player has made a move. So that's what these even values give us. The odd values just give us these vertical lines. So the odd values in the columns give us these vertical lines, and the odd values in the rows give us these horizontal dashes, or these horizontal separators. So yeah, let's go in here, and what we want to do is we want to change this print statement to something a little bit more general. So what do we want to do? We want to print the corresponding element in the current field. So we're going to go into our current field, and well, locally here it's going to be called the field. So we're going to go into our field, and what we're going to do is, since our field is going to be structured column, 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 the first thing that we want to do is we want to access the column. And the second thing that we want to do is we want to access the row. So what we get here is we get our columns, column, 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 column here, and then each of these columns has row, row, and row. Now, we're running into a little bit of a problem, and that's because we're going through the range from 0 to 5, so we're taking on the values 0, 1, 2, 3, 4 for our columns, and 0, 1, 2, 3, 4 for our rows, but our field actually only has 3 elements, so 0, 1, 2, and each of these elements has a list itself which only has 3 elements, so 0, 1, 2, and those correspond to our columns and our rows. So we're going to need to adapt our rows a little bit. And so what we want to do is we want to be able to change this column here, or this column here, and this row here. We want to change it from 0 to 4 and 0 to 4 to either 0, 1, or 2. So what is a smart way that we can do that? Now, of course, there are different ways, so I could completely change my draw field function, and I can only loop from 0 to 5, and I can say, I print my value, and then I print the separator afterwards immediately, without using a else statement and stuff, and I have special cases, but we don't really want to rewrite our whole draw field function. We're a little bit stubborn, and we're going to say we wrote this once, we're going to figure out a way around it. So how are we going to map our columns 0, 2, and 4 to the numbers 0, 1, and 2? So what do we want? Well, let's just kind of write out what we want so that we can visualize it. We want to change 0 goes to 0. We don't really care what happens to 1, since we're not going to use it. 2 goes to 1, and we don't really care what happens to 3. And 4 goes to 2. So 0 goes to 0, 2 goes to 1, and 4 goes to 2. So what are we doing? Well, effectively, we're dividing our columns by 2. So that would be one way to get these values. So if we divide our column by 2, well, 0 stays at 0, 2 actually goes to 1, and 4 goes to 2. So cool. What we've just did is we found a nice mapping. So we've run into the problem that we're going through the values 0, 1, 2, 3, 4, because we're going kind of column by column, and we're also printing the vertical separators. And here for the rows, we're printing the horizontal separators. And we need to figure out a way to map that to columns so that we can use index 0, 1, and 2. And so we found a way to do that. So if we divide our columns by 2, and this only works for some, of course, but it works for the ones that we're interested in. So we're lucky. So now we figured that out. We've said, aha, well, technically if we divide our columns by 2, that would give us the right value for the column, but how are we going to implement this? So inside of this if statement, let's just create a new column or a new variable, and we'll call it the practical column. So the practical column is the column that we can actually use in our field to access the variable. So rather than having the column value, which takes on 0, 1, 2, 3, 4, we're going to have a practical column, which is going to take on values 0, 1, or 2. And since we only change the practical column when our column is even, or if we divide it by 2, we get a remainder of 0. So what we can do is our practical column is going to be equal to the column value divided by 2. So what are we doing? Well, our column takes on the values 0, 1, 2, 3, 4. Now if we divide column by 2 and we get no remainder, then we assign a value to a practical column, which is the value of column divided by 2. And so the only values that pass here for columns are 0, 2, and 4. And this gives us the values 0, 1, and 2 for our practical column. So we can actually use our practical column in here rather than our column variable, and this is going to give us the columns that we want here in the field. And now we can go up here and, well, we want the same thing for our rows. So just like for the columns, we want 0 to go to 0, 1 we don't care, 2 goes to 1, 3 we don't care, and 4 goes to 2. So we can do the same thing in the rows, and we can create a new variable called practical row, and it's just going to be equal to our row divided by 2. And since we're only going in here when row is even, so if we divide row by 2 and we get no remainder, so the only values that go into this if statement for row is going to be 0, 2, and 4. And for these values of row, our practical row is going to have the values 0, 1, and 2. So, I mean, what we've did is kind of complicated in some sense. So we ran into the problem that our row and column take on the values 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. But we found out a smart way to get around that. So to get values 0, 1, and 2 when we need them, we were able to kind of create a mapping where we've created a new variable that is equal to the column divided by 2, because that works out nicely to give us the actual column that we want. So rather than having to rewrite our whole draw field or to add extra if statements or extra checks, we just sat back a little bit and we thought, well, what do we want? We wrote out what we wanted. So what we need is 0 to go to 0. We don't care about 1. We need 2 to go to 1. We don't care about 3. We need 4 to go to 2. And so we were able to create a nice kind of relation, drawing this out and really understanding what we need. And of course, we're lucky that we chose 0 to 5 rather than 1 to 6, because if we chose 1 to 6, then we would have to do some extra math. For example, we would have to subtract 1 away and then divide by 2 or so. I mean, it would all still be doable, but we would just have to figure out another way to get around it. Or, of course, we could rewrite our whole function, but we already wrote it, so we want to keep it. And now we figured out a nice way to actually get the practical column here and our practical row here. So, yeah. So this is kind of a nice example of using what you already have and trying to figure out what you want to get. And the nice thing is that we can just create new variables, and all we had to do is just divide the value by 2 when we needed it, and that gives us the right value for the column and for the row. And so creating these new variables is also just a really nice kind of technique that you can use. You can always create new variables, use them when you like, use them to make your life simpler. And so we were able to create 2 new variables, and we saved ourselves a lot of time rather than having to rewrite our whole draw field function or rather than having to create a bunch of special if statements or other types of checks, or if else, if or else statements. Um, and also here inside of the space, we'll just put in. We also want the field and the practical column and the practical row. So we went from the hard-coded version of just printing an empty field to the more general version of printing the field that we have here. And so we put that in there. So yeah, so this is kind of all a little bit weird, and it's a little bit complicated. So let's just run our code once, and then let's go through it a little bit, and let's really understand what we did. Yeah, and so let's make use of this draw field function. Let's draw the field first. So we'll call draw field, and our field here is actually going to be the current field. And then instead of printing the current field, let's take this out and let's call the draw field function. And in here, our field is also going to be the current field. So all that we've done here is, instead of printing this list, we're actually using the draw field function that we created earlier that draws our field. And we'll draw it once in the beginning when it's empty, and then we draw it every time after a player makes a move. So if we make this bigger again and we run our code, let's see what we get. Well, we get an error. So the list indices must be integers or slices, not float. So what we forgot up here is that since we're dividing by 2, we actually get values of 0.0, values of 1.0, and values of 2.0. So what this error is telling us is that we need to have integer values, not floats. So integers are whole numbers, floats are decimal numbers. So we need to convert this to an integer. So we are going to put our integer around here. And what this does is it just kind of cuts off the decimal numbers, and it converts 0.0 to 0, and 1.0 to 1, and 2.0 to 2. So for us humans, it's not really that big of a difference unless you're really technical and stuff. Then yes, 0.0 is technically different than 0 because of accuracy, but generally we say 0.0 is the same as 0. But for the computer, there actually is a big difference. And so we also need to do that for the row. We need to have our integer around here. So before we had 0.0 and 1.0 and 2.0, but we can't put that in here. So we can't put in 1.0 for our column. We actually need whole numbers of 1, 2, and of 0. So we need to convert this to an integer. So if we divide, we actually get a float or a decimal number, but we need it as an integer. So we've changed our practical row to be an integer, and our practical column also to be an integer. So if we run it now, we see we get the empty field printed. So now everything works. So really the problem was that if we divide by a number, we get decimal numbers. So we had to use this integer conversion here to convert the results to an integer from a decimal number. So it's player 1's turn. Let's enter the row. Well, our row is going to be, let's put it in the top left corner. So we're going to have row 0, so row 1, row 2, and row 3. Let's use row 0. And let's also have columns 0, 1, 2. So to put it in the top left, we'll put in column 0. And so we see when we print our fields, we've now put in the X up here. And now it's player 2's turn. And let's have player 2 put it in the top right corner. So the row is going to be row 0, 1, 2. So we want to put it in the top right, which is row 0. And our column is going to be 0, 1, 2. So our column is going to be column 2. So we see player 2 put their move here in the top right corner. Now let's say player 1 puts theirs down here. So that would be row 0, 1. and that's going to be column 0. So player 1 puts their move down here. And now let's say player 2 puts their move in the middle, which is row 0, 1, and column 0, 1. And now it's player 1's turn, and player 1 is going to put their move down here. So enter row 0, 1, 2. So row 2, column 0. And so player 1 has kind of won the game. But our program isn't ending because we're not really checking for that. And so those are things that we could add later. So for example, another thing that we're not checking for right now is please enter the row. So we could technically overwrite this. We could overwrite, well, if we go row 0, 1, 2, and if we go into column 0, we've now changed our X to an O. So we've kind of overwritten the move that player 1 has made before. So these are some little kinks and bugs in our program that are still taking place. So we can stop the code, and we can fix those using simple statements. So we could check, for example, first here. So how would we fix this? Well, we have to add if statements where we would check, is the value empty? If it is, then we make the move. Otherwise, the move is invalid and the player has to make another move, and we could do that down here. So how would we do that? How would we stop this overwriting? So we could make a simple if statement in here, and we check if, and then if the current field in our move column and our move row is empty. So if in our current field our move column and our move row is empty, is equal to a space, so that means it's empty, then we can do this. And now if it's not, well, we're not going to do anything. And well, what happens then is, since we're not entering this if statement, so we only enter this if statement if the current field that we want to move into is empty, then we can make our move, and then it's player 2's turn. But if it's not, we don't do any of this, and we go out of this if statement, and we also don't execute this because we were inside this if statement, and we just print player 1's turn again. And we just kind of continuously ask for player 1's input until it's valid. We can do the same thing for player 2, so we can check if in the current field in our move column, so in the column that we make the move in, and in our move row, if this is empty, so our empty corresponds to a space value. So if this value is a space value or empty, then we do this. Otherwise, we just don't do anything, and that automatically makes it that the players that it's not a new player's turn and stuff, and that just kind of leaves it as it is. So let's run this once to see the changes that we've made for this kind of simple override bug fix. So now it's player 1's turn, and let's put our value in the top left corner again. So that's row 0, column 0, and let's enter let's as player 2 try to overwrite player 1's turn. So we'll also try to put it in the top left corner. So row 0 and column 0, but nothing has happened, and we see that it's player's 2 turns here. We try to put it in the top left. It's still player 2's turn. Let's be stubborn, and let's try to put it there again. So row 0, column 0, still player 2 turns. Nothing's changed in our field. We'll concede. We'll put it in row 1, column 1, so in the middle, row 1, column 1, and now we see it's player 1's turn again. So now we have this simple kind of bug fix that the players were able to kind of overwrite each other's moves. So that we were really nice and simply able to do by just checking if the current field's value is empty, then we can add a new value. but if the value is not empty, so if this value is an X or an O, then we don't. Then we don't overwrite it. So for example, that also prevents the player from losing their turn by putting their move in the same spot. So if player 1 now tries to put it where they put it before, so row 0, column 0, also nothing happens. It's still player 1's turn, so they also didn't lose their turn. So maybe they put it down here again, which would be row 0, 1 in column 0, and now it's player 2's turn again. So we fixed the simple bug fixes that players can't really overwrite the game board, just through this simple if statement. And now we can expand on this example by checking if someone has won. And so we'd need to create several if statements to check. So how do you win a game? Well, you get 3 in a row, either vertical or horizontal or diagonal, so that's how you win the game. So after each turn, you could make a lot of if statements to check if someone has won a game. We're not going to do that here, just because it's adding a bunch of if statements, but these are all things that you can kind of do to make this game even more complete. But what we've created here is a very simple tic-tac-toe game, where we print the fields. We ask the players to put in their rows and their columns where they want to put their values. And once they do that, we put their value in the corresponding spot. We start off with empty fields, and we put in the values that they entered. We don't allow the players to overwrite each other just by having this simple checking mechanism here. We also found a very smart way to draw the field, and we've also created this very simple mapping. So columns 0, 1, and 2, and rows 0, 1, and 2, we were able to kind of map that and use our draw field function that we created in the beginning. So we've created this draw field function, and we saved our values in a kind of list which contains lists that resemble or that displays our current field in a list format, and we drew these list formats in the form of this field using a lot of print statements and for loops. Yeah. So, I mean, we've actually done something really cool. We were able to create a simple game. I mean, the game isn't complete, of course. We need to actually check when someone has won. But like I said before, this checking isn't too difficult. You just need to add if statements in the end. And you need to check, are there 3 in a row vertically, are there 3 in a row horizontally or diagonally, like this. So those are the ways that players could win. But we were able to kind of print this tic-tac-toe field to the screen. We were able to ask the players to input their moves. We alternated between players 1 and 2. If someone puts in an invalid move here, we don't do anything. We just ask them. We just kind of prompt them to do it again. Yeah. So this is kind of our first example of creating something really cool and practical. And we've used a lot of very good skills or very kind of common skills, just asking for user input, using simple loops, printing to the field, using if statements or else statements to check if things are equal or not equal, using lists to store data. So we've used all of our knowledge, and we've created something really kind of almost complex and complicated and very intricate, just by kind of using our imagination and expanding on the things that we know and using what we know to kind of push it to the boundaries and create this simple tic-tac-toe game.